Thank you so much for joining us for our next session. I'm Kelly Hill, Executive Editor of RCR Wireless News, and I'm pleased to welcome Owen O'Donnell, who is Terra VM Marketing Manager at Viavi Solutions. Welcome, Owen. How are you today?
I'm very well, Kelly, and looking forward to this session. Thank you for having me.
Wonderful. Well, you're going to be speaking on whether or not the RIC is the key to true openness. So please go ahead and get us started.
Okay, well, thank you very much. Yeah, so as Kelly said, this short presentation will talk about the RIC in all its forms. And just to kick off, so people who don't know me, my name is Owen O'Donnell. I've worked in telecoms for over 30 years now. I've spent most of that time with Ericsson and Huawei, and I'm now working in test and measurement with Viavi for the past 6 years. And my current role is head of marketing for Terra VM, which is one of Viavi's lab-based test solutions. So today's agenda is going to talk about the RIC, both the non-real-time and the near real-time RIC, and their architecture, their specification, and what's the main difference between them. Then I'm going to look at some of the RIC's opportunities and use case applications. Then I'll talk about the barriers and operational issues to implementing the near real-time RIC. And then I'll have a quick look at how to standardize in different RIC environments. And then we'll see how we're fixed at the end, but we hopefully will have a bit of time for one or two questions. So to kick off and explain where the RIC has come from, I'm going to start off with a little history lesson. So around 2010, we had SON, which stands for Self-Organizing Networks. And the first one of those was something called CSON, which is Centralized Self-Organizing Networks. And this sat on servers deep into the network and took feeds from many radios and took a RAN-wide view. It performed calculations and fed back changes with the ambition of improving the network. And alongside that, we had the DSON, which is the distributed SON. And this was more located close to the base station. And it had software which was looking after just the functions of that base station itself. However, the software of the DSON was tied to the base station manufacturer. So there's a very strong tie-in between the two of them. Now, over the years, SON has not really taken off for a couple of reasons. The first one being that the incompatibility between SON vendors and base station vendors, it had to be tied up between the two. So you had to buy the same SON from the same base station manufacturer. Also, there was actually very little value adding to network improvements because of SON as it transpired. And then thirdly, the turnaround changes, the time changes for things to take effect was actually quite long. It was about 15 minutes for SON. And during that time, an awful lot can happen in the RAN. So it wasn't actually proving to be too effective. So RIC is in essence a rebranding of SON. And the DSON, the distributed SON, is paving a way for the near real-time RIC, which I'll talk about in a few moments, while the CSON is being replaced by the non-real-time RIC. And it's no coincidence that RIC is happening as Open RAN technology takes off. So RIC itself stands for RAN Intelligent Controller, and it's defined by the O-RAN Alliance, and it's standardized by one of their working groups. And it has open interfaces and APIs, allowing service providers to pick and choose, firstly, the best of breed RIC to sit on their network, and secondly, the best of breed XApps and RApps to sit on their RIC. So the RIC itself is sometimes called the next generation SON for Open RAN. And it brings to the market so much more than SON. So it's open, it's standardized, it comes in two forms, a near real-time and a non-real-time. And it's capable of housing network management applications called XApps and RApps, which are developed by either the RIC vendor themselves or by third-party vendors. Now, if you remember that operators spend billions of dollars on 5G spectrum, and then millions more on new radio units and base stations and small cells and core networks and transmission hubs, and then more again on services to get the systems up and running and tuned and working. So the total cost to an operator for 5G is billions of dollars. So how can the operator maximize the return on this investment? Well, the usual ways come to mind, and that is attracting subscribers and keeping them, encouraging them to use costly services and apps which use lots of data, but also by running the RAN as close to maximum efficiency as possible. So keeping it available 24/7, ensuring subscribers have the best quality available, and getting every last call and data session out of the available spectrum it can. And this is where RIC comes in. So the main purpose of RIC is to automate and optimize the RAN at scale with the end goal of reducing the mobile operator's total cost of ownership. So quickly, the difference between non and near real-time RIC. So the near real-time RIC manages events and resources that require a very fast response time. And we're talking down to 10 milliseconds. Now, the near real-time RIC, it uses closed-loop measurements such as data analytics, inputs from the other RIC, the non-real-time one, artificial intelligence, machine learning algorithms to optimize traffic, to optimize mobility, to optimize load, to reduce energy consumption, and other improvements across multiple radios. The near real-time RIC tends to be located close to the network edge to assist in low latency transactions. Whereas the non-real-time RIC, it manages events and resources with a bigger response time of kind of 1 second or more, so less urgent messages. And the non-real-time RIC operates from within the Service Management and Orchestration Platform, also called the SMO. So I mentioned in a previous slide that the RIC platform supports XApp and ORApps, which are specialist control applications which help automate and optimize RAN operations. Now, we, as in Viavi, we're seeing XApp and ORApp developers coming from 3 different types. We're seeing the RIC vendors themselves, we're seeing research bodies and universities, and we're seeing third-party startup companies who have spotted an opening and don't necessarily have the telecoms background for more complex infrastructure development. So they see these XApps and ORApps as a way of getting into the industry. But the RIC is going to become a key differentiator for network operators to attract new customers, because they can show using real statistics how their network is outperforming the competition. So I expect to see bake-offs between different XApp vendors who are vying for operator business, claiming that their algorithms are better than the other by showing that they can make a percentage improvement in a network KPI. And this will potentially open up a new type of integration lab, I think, for XApp benchmarking, where XApp vendors will look for some kind of certification or badge to show and say that they've outperformed their competition. And as with any network element, the unknown and the risks can be mitigated against by testing, which is where Viavi come in. So from a standards point of view, there are certain numbered interfaces such as E1 and A1, or sorry, E2 and A1 and O1 involved in the 2 types of RIC. And these are really important because they carry the data and the messages and the instructions between the RAN and both RICs. So the diagram on the left here from the O-RAN Alliance shows the various interfaces between the Open RAN nodes. And you can see the E2 interface is the important one from a near real-time RIC perspective, which has connections from the ODU and OCU into the near real-time RIC. Note the E2 interface shown here in green, it's currently an O-RAN interface, so it's not yet a 3GPP interface, unlike some of the other interfaces in telecom, such as X2 or XN or F1. Now, the RICs, both near and non-real-time, and E2, O1, A1 interfaces, they're all specified by O-RAN line specifications. Now, on screen are a list of the documents which need to be referred to and complied with when developing a RIC or an XApp or an ORAP. And these can all be found on the O-RAN Alliance website. So moving on, and the RIC, some people think, is the final piece in the disaggregation puzzle. And what we mean by that is, if you look at the top part of this diagram, this is where we've come from. So 2G, 3G, and 4G generations consisted of mobile equipment where vendor lock-in was the norm. So you had proprietary hardware, you had proprietary interfaces, you had no interworking between vendors. Operators had to buy from one from the same vendor for all components, and one vendor controlled everything within an operator's network. But the lower half is where we're going with Open RAN and RIC. So 5G has enabled an Open RAN. It has a new function, intelligent function called RIC. We have an XApp ecosystem. We have core network disaggregation and a complete open, more efficient, competitive, and innovative mobile ecosystem. But also, if you look across the bottom, you can see that we've got up to 8 different vendors now supplying some piece of network equipment into an operator's network, giving operators a huge choice to pick best of breed components, drive down cost of goods, encourage innovation, and allow them to differentiate their network from their competitors in the hope of attracting more subscribers. And RIC is at the heart of this diagram. So when it comes to use cases for RIC, there are literally hundreds of possible ways the RIC can be used to enhance the running of the RAN. Now, the E2 specs, which I talked about in the last slide, they define service models, which allow the transfer of KPIs and counters and data from the RAN to the RIC, where they can be consumed by XApps written for a specific application. Now, what drives the development of these XApps is actually operator driven. So operators will want XApps that make the RAN more efficient, that will make the user experience better, that will reduce energy consumption, that will maximize spectrum use, that will maybe anticipate some kind of signaling storm or attack. Basically, the list goes on and on. So we, in fact, sent out a list of over 40 use cases and asked operators to rank them from highest to lowest. And on screen, you can see the top 17 use cases that they picked. So you can see basically a mix of results with customer user experience highest. Then we've got spectrum efficiency. And we've also got energy saving and network slicing as the type of use cases the operators are seeing. But we're also seeing a pattern in XApp development with quick win ones first, those that are relatively easy to implement and not too risky to launch, for example, traffic steering or energy saving. But I think later in the coming years, we'll see more complex use cases like signaling storm detection or RIC security-based applications coming on board as the RICs become more commonplace deployed and the standards become more mature. So if we take a look at a couple of use cases, and the first one I'm going to talk about is the traffic steering use case, which basically shows how 3 XApps can work together to identify a problem, look for a resolution, and then affect a change to improve the situation. So the way this works is you've got, first should I say the key to testing these XApps is having a RAN emulator, which is our RIC test product shown on the bottom left of the screen here. So when you've got a RAN emulator, which can emulate UEs, that is mobiles, which can be either stationary or they can be pedestrian walking slowly, or it could be a vehicle driving at a speed. And if they're all running data calls, then we can create an anomaly in the cell where those calls suddenly start feeling or experiencing a degradation to their throughput. And that's where the XApp comes in. So when that happens, the first XApp, which is the anomaly detection, that has the task of looking and monitoring the KPIs basically of each UE. And based on historical data, it looks to capture when an anomaly or degradation occurs. That's all it does. So once it confirms that there's an anomaly or a degradation to the UE, it passes a message on to the next XApp, which is Quality Predictor, to perform the next task. So Quality Predictor XApp then has the task of looking at alternative ways of improving the quality of this ailing UE. So it basically looks to see whether the UE could be handed over to a different frequency or to a different cell. And it uses KPIs and runs algorithms to see what effect would be on the UE if it performed a handover, but also would there be an effect on the other UEs that the cell that being handed over to is in. And all of this occurs in real time, by the way. So if it decides a handover is the best course of action, then it triggers the third XApp, which is traffic steering. And his job is basically to tell the RAN to move that user from one cell to another. And when that happens, you can see on the screen, you can see that the traffic throughput improves because of those three XApps working together. So it's a very simple way of showing how three XApps can monitor a problem, then can move the UE to a different cell where it thinks it will have an improvement, and then we can measure that improvement to see that the effect has actually had an improvement. And then a second one, which is actually a very popular use case, high up on telco's priority list, is energy saving. So not only can energy saving reduce one of the larger operators' OpEx costs, but it can also satisfy the operator's ambition of becoming carbon neutral and trying to reduce its CO2 footprint. And the way this works is, so first of all, according to a recent report by GSMA, actually, the energy consumption of an operator's network consumes between 20 and 40% of the entire OpEx cost. So it's a huge amount of energy that's spent running a network. And while 5G networks are actually more efficient than 4G, but then they start consuming more power because of the increased throughputs demands and the hardware required to meet those demands. So network operators are always looking at ways to reduce power consumption without affecting the coverage or the capacity or the user service. So the way in which they can address this with the RIC is, first of all, the RIC needs to understand where and when and how much energy is being consumed by the RAN, basically power monitoring systems. And then once those metrics are known or available, then the RIC can use some smart methodologies and algorithms to decide when power management actions, in addition to those already defined in the standards, can kick in. So a simple example would be turning off a cell during quiet hours and saving huge amounts of energy. So this is an area where I think we'll definitely see early movement when it comes to XApp development for RICs. So what are the barriers and operational issues to implement the near real-time RIC? Well, the three biggest barriers that I see are, first of all, compliance, and that is ensuring compliance to standards. So any RIC vendor needs to develop their RIC fully compliant to the O-RAN Alliance E2 specification. And how you ensure that is through test. So if you use a RIC test product, such as Viavi's, you can send E2 compliant messages according to the specification and make sure that the RIC interprets the message correctly and returns a valid response. That's how you check for compliance. Secondly, interoperability. So as the RIC is designed to be part of the Open RAN infrastructure, and as I showed a couple of slides back, it will interact with many different components from potentially many different vendors, then interoperability testing needs to be done in the lab to ensure everyone is singing from the same spec hymn sheet and each can interact correctly. And then very importantly is trust. And this is basically the placing trust in a new function which can make real-time changes to a RAN without a human checking them is a very big barrier for operators to overcome. So how sure will operators be that the output decisions of one XApp will make a RAN better or worse? Or even how will they be ensured that one XApp won't outdo another XApp, for example, and do a negative or an opposite effect? So there's a lot of trust that the operator needs to gain, and that can only be done through thorough testing in the lab prior to being let loose on the live network. And then that brings me to the final slide of this presentation, and that is how to standardize RIC environments. So first of all, RIC environments can exist because the E2 interface is open. So operators are basically free to select a RIC vendor of their choosing and any XApp or ORAP vendors who have been proven on that RIC. Secondly, we have these things called plug fests, where you've got multi-vendor plug fests. And these are happening regularly with O-RAN Alliance, hosting 2 plug fests every year now in many different global locations. And it's at these plug fests that RIC vendors and XApp and ORAP vendors and RIC test vendors such as ourselves, they come together and they show how their solutions are working together, thereby giving confidence to operators that live deployment is in fact safe. And then we have ORAN Alliance and TIP, which also host things called certification and badging, where Open RAN equipment such as RIC can be certified under third-party auditing to work against the standards and against other named equipment. And this too will pave the way for a quicker adoption of RIC and XApp products into the network. Okay, that brings me to the end of this session. So I hope you enjoyed it. And I think we may have time for a question or two. Is that true, Kelly?
That is true. Thank you so much, Owen, for the presentation and for all of that perspective. We do have a couple of audience questions, but I think that you got into this a bit, but I just wanted to start off by asking, can an operator choose XApps or RApps from any vendor to run on the RIC? Obviously there's questions and I'm sure concerns about interoperability.
So potentially, yes. And that's the great thing about the RIC, that it is completely open. So the RIC vendor, first of all, they must agree to support the application and test it first. So while many RIC vendors will bring to the customer, or sorry, to the operator, XApps that they've already onboarded, you could say, from different vendors around the place and some of their own, the operator can actually say to the RIC vendor, well, I've got one preferred XApp that I've been investigating myself. Can you house it on your RIC? And the RIC vendor will probably say yes, but we need to make sure it's compatible, that it sits on our platform, whatever that platform, it could be a cloud hosted platform, that it sits there and it works. And that's a lab test that they have to do. So I'm just going to say potentially yes.
Okay. I'm going to move to one of the audience questions. And the question is, does the RIC handle functionalities like the MAC scheduler, radio resource management, SON today, which are the real-time sensitive functions of the RAN from the past? So, and if it doesn't handle those today, do you think the functionalities aren't needed to handle at the RIC level in order to make the RAN open? So
okay,
that's a mouthful.
That's quite a mouthful. So if I think I understood the question correctly, I think that the part answer is no. So radio resource management and scheduling, that's still part of the base station components. So that's still not taken away from the base station and the CU and DU. So that all has to continue running as a normal part of a base station. Okay. However, the context awareness and the additional machine learning that can be done outside of the base station while the scheduling and the radio resource management is going on, that's being done on the RIC. So it's like it's taking this umbrella look or overarching view of what's happening and saying, well, actually, we've watched what's happening and we can improve that even further. And that may result in the RIC sending something back into the radio resource manager or the scheduler and saying, do something slightly different. So it kind of, it complements what's already happening in the base station. So I hope that that answered the question there, Kelly.
And I imagine the fact that it's complementary probably takes maybe some of the risk out of it. You talked about how some of the things that operators are looking for this are really in things that, if your traffic steering is a little off, or if some of these other things, if it's a process to optimize, then it's not quite. Let's hand all our radio resource management over.
No, you're right. It's complementary, and it's great that it can use additional sources of input which wouldn't be readily available for the base station, and that's where this contextual awareness can feed into the decisions the RIC makes, and it just makes the overall running of the RAN more optimal because you've got a lot more to choose from, and the fact that it's done in real time means that you're not having to wait a while to make a change because things happen so quickly in the RAN, obviously.
Okay. Just one more question. When do you think we'll see commercial deployments of the RIC?
So I would say that there's a huge amount of, the RIC has been standardized now. Well, it's being standardized for the past 2 years, and we are talking to a huge number of customers. And the feeling I'm getting is that it's going to be deployed in some form commercially in the next year, 2023. And then I would say it could be in 2/3 of networks commercially by 2026. It's going to take a little while for things to launch because, as I said in one of the slides earlier, trust is a huge thing. And, operators will launch with safer XApps first, like traffic steering and like energy saving, where it won't have the biggest effects. But I would say they'll also probably launch on rural sites, maybe, where they can kind of they won't have the biggest impact before they go into the urban sites or bigger network.
Great. Thank you so much, Owen. We really appreciate your time and your perspective. Please join us for the next session, folks.
Okay. Thanks very much, Kelly.